It's George Tyndall, and I'm back again. Now, I know that there's some people out there that are upset because of what I've been doing, and I apologize. I had to do what I had to do to try and get someone's attention. Now, the video that I'm making this time is going to be important. There's going to be no joking. And if afterwards, after you watch it and listen to what I'm saying, if you want to criticize me, fine, you're more than welcome to. Time is running out. I cannot do what I'm doing alone. That's why I'm doing what I'm doing. Okay, now with that being said, I'm going to show you two clips. Okay, and then I'm going to get into where I'm going with this. But I have to show you the two clips in order for you to be able to understand. Some people will know this, some people won't. I have to try to get everybody on board. Okay. Now we're going to the clip. The first clip is this. Okay, now this is extremely hot metal being put into water. It's called quenching. That's what can happen. Okay? But that one doesn't make as good of a noise. So, I have another clip here. Now this is going to be metal quenching, put into water. Listen to the sounds. Now, you have to keep those two little clips in mind when I'm going through where I'm going with this. The metal being quenched and the sound. You've got to keep that in mind. Okay, now I got to go to my place. I'll be back in a second. Okay. Now that we've gone through that part, we're going to go through this part. A lot of people say that, this can't be this and this can't be that. Well, that's wrong, and the impossible can happen. Now, with that being said, we're going to go to this rock right here. Okay? That's a picture of it. Okay? But when you turn it at an angle, you get that. Now, you can see the metal, but you can still see a little bit. You can still see a little bit of the coloring. That's because the coloring is mixed in with the metal. See? See the metal, see the coloring. See the metal, see the coloring. See the metal, see the coloring. Okay. Now what is that? I figured it out because people said that it's impossible for a meteorite to be iridescent. Iridescent is when you take a rock and you angle it, and it will change. Now, because this is metal, and I'm going to explain why it is, this is metal too. Now, they're not really two different types of metal. It's the same metal. But I'm going to show you how the metal obtains this property. Okay, now I'm going to show you this. Okay. That is metal too. It doesn't look like it. It looks like rock. Okay. But it is metal in rock form. Same way with this one. Okay. It's metal in the middle, and it's still got rock around the outside of it. But this rock around the outside of it is metal too. Now, how can that happen? How can that happen? How can everything like this be metal, different types, but be in complete rock form? All right. How can metal be in complete rock form? Okay. And how can metal be iridescent? Okay. You have to look up a lot of things and do a lot of research in order to be able to understand this. Okay. Now, there's such a thing called oxide layer interference, calcination, and roasting. Okay. Roasting is a process of metallurgy where ore is converted into an oxide by heating it below its melting point in the presence of excess air. Okay. Now, oxygen is abundant in the minerals of stony meteoroids. What is air made of? Oxygen is one of the three gases. Okay. Is it dangerous to boil rocks? Okay, it depends on the rock and whether you use water afterwards. Okay, the rock will crack, disintegrate, or it will stay as it is when you boil it. It'll either crack, disintegrate, or stay as it is. Stay as it is if it's boiled. It is possible oxygen and hydrogen react in the mesosphere, forming water. But like the ice crystals in noctilucent clouds, which I've been trying to tell people, okay, water would need a hard surface upon which to react. Meteoric smoke, the plasma trails, might provide the necessary surface for that. A drop of water can spend 9 days in the atmosphere before falling back to Earth. Okay, so we have water in the atmosphere and plenty of it up there. There's also such a thing called cold forging. The disadvantage of cold forging is it can't be used on every metal because certain types are more likely to crack or break during the process. Now, with that being said, I'm going to go to the main picture and people will start to get it. This is where it gets really interesting. Okay, but you can't come to these conclusions unless you find this stuff. If you search for this stuff and you find it, you have it to be able to examine, to be able to come to these conclusions. Okay? Now, during the 1833 meteor shower, it wasn't a normal shower. Okay? What happened to those? And these are rocks from space, what happened to them is they came in, okay? They came in. In the mesosphere, they were roasted. The rocks and the metal was roasted. Okay? The sprites converting ice crystals to water dropping the temperature and basically boiling rocks in hot water. Now, they said that they made some people heard a whoosh, whoosh sound. That would be taking your piece of super hot metal and it would be hitting that water. It would whoosh. If this is making sense to people. Now, I'm trying to explain this. Okay, the meteors would have went through a roasting process and then a quenching process. Because there would have been all that moisture up there. And a lot of it's common sense. If you have over 1 million meteorites in an 8-hour period, 250,000 visible at one time, that is a lot of meteorite smoke, plasma trails. Okay? You have to factor everything in to be able to figure this stuff out. And the science is there. The science is there. I've looked it up. This does this. This does that. All you people out there, you put the stuff out there. Okay? And I put all this together. Now, how do I know? Okay? And that it isn't a bunch of BS. It's the stuff that I'm showing you. I have the stuff. Why is it different? Okay? Why is this one different than this one? Okay? Why is this different? Why is this different? Why does this one look different? Why does this different? And why are they all metal? Why are they all metal and they look different? It's the reason why when you roast metal or rock, it's going to obtain its same properties. And you saw how hot the metal was, but the metal was below the melting point. Metal can sit there and cook and cook and cook and cook. Metal can get hotter. It can get red hot. It can get white hot and not melt and not change. Now, if metal is roasted, okay, this rusted inside, okay? This is rust. And that's because this right here looks like rock, but it is actually metal because it was roasted. Okay? What turned the outside part to where you can see that it's metal is the friction from the blade cutting the rock. It gave it just enough heat to turn it to metal. Okay. Now, I have to keep this in the water. Okay, now, this rock got hot at some point from boiling, roasting, whatever you want to call it. Okay, but here is different than here, and it fractured. Now, I got to go grab another rock, so we're going to take a time out for a second so I can explain the fractures on the inside. All right. Now, this, whether a person wants to believe it or not, because you can turn it at an angle and all the little metal freckles is different metal that heated and cooled. All metals have different heating points and different cooling points and melting points and stuff like that. Okay? And people out there already know this stuff. When I turn this at a little bit of an angle, I can see the metal. Okay? But it obtains the coating because the inside was boiled. And so basically the coating was transferred to the metal. Like I said, after the video, you the choice to believe it or not or whatever. Now, on this side, where this comes apart, all those cracks right there, the metal couldn't take the stress, so it fractured. But this is metal. It's metal too, whether people want to believe it or not. But it's rock on the outside. Okay? When you can get, metal will just get extremely hot and keep getting hot and keep getting hot and keep getting hot if it never gets to its melting point. It will just heat up and heat up and heat up and heat up. Now, the effect that it had in the mesosphere, okay, is similar to you dropping this in water, boiling it, just like an egg. It looks just like an egg. There's your yolk and there's the outside part. Now, with that being said, people can either believe or they can either disbelieve or not or what they want. I got one more thing to say. If you get a big asteroid, that's coming toward the planet, and it goes through the roasting and the quenching effect, because it comes in during one of those when there's when it's loaded with plasma to produce all of this meteorite smoke. This asteroid is going to come through here, and it's going to convert from rock to a very heavy rock metal, just like this stuff. It will get, your asteroid will probably weigh 2-3 times what the rock coming in weighs, because it will convert. It will convert to this type of rock metal, and it will make it heavier. So your impact is going to be more devastating. Now, eventually, this is probably going to happen. I'm trying to help. But it's up to you people. It's up to you people. If you want to live, then someone needs to check out what I'm saying. If you don't want to live, then fine. Call me a stupid idiot. Call me crazy. I don't care. And I will call it good at that.